So 5 minutes is up. We're going to head and get started here. Make sure you join the Pear Deck if you haven't done so yet. Okay, joining it, that's how you get your attendance credit. Along with joining the meet to get the full attendance credit, you need to be in the Pear Deck and participating as well. Hi, Nayeli, welcome. All right, so let's see what we came up with. 10 of you responded. And a couple of you said it was -2. One person said 4. Quite a few of you said 2. So the coefficient of the y term, we have 4 minus 2y. And so when we look at our terms, this is actually could be rewritten as 4 plus -2y. So -2 is actually the coefficient of our y term. -2 is the correct answer here. So you can move your star over to -2. It should be on -2. And it's a little bit tricky. So, I mean, I know why you put 2 if you did put 2, because you're just looking, oh, there's the y, there's a 2 in front of it. But when you have a subtraction sign here, it belongs to this term. Okay, and that's important when we're working with polynomials, to remember that, you know, if the stuff's added together, the terms are added together, it's easier to see the coefficient. But when it's subtraction, you can always rewrite it as addition, as adding the opposite. So this is the same as 4 plus -2y. And -2 is the correct answer. All right, so this is what we're doing today. We are doing more stuff with polynomials. We're subtracting polynomial expressions. And this goes with 17.3 in your text. Your essential question, how do you subtract polynomials? Your learning goals, I can explain how to subtract polynomials. So as we get started in this, you know, we've already learned a little bit about how to subtract polynomial expressions. I mean, how to add polynomial expressions. We've learned a little bit about polynomials last week. So last week we actually learned 3 different ways to add polynomials. And the way you do any of the methods is by combining like terms. So we use that website, and we're going to be using that same website again to use algebra tiles. We also learned the vertical method, where if you have 2 polynomials, you want to add them, you line them up so that all the same types of terms, all the like terms, are stacked above one another. And if you're missing a term that you needed, you had to put a 0 to kind of hold its place there. So to add this using the vertical method, we would do that and then simplify it. We also learned the horizontal method, okay, where you have a polynomial and another polynomial, and then you rearrange all the pieces so that the like terms are together in a group of parentheses. So the 2 x cubed terms are here, the 1 x squared term is here, and the 2 x terms are here. Like terms and polynomials have the same variable and the same exponent on the variable. All right, and that's how we can combine these and simplify them. Okay, you can use any of these methods. When we used the website with the algebra tiles, that was really good when the coefficients were smaller numbers. So these polynomials, both of these examples where we're adding, would be fine to use algebra tiles for as well, because coefficients here, there's a 1, -1, 1, -1, 2. Okay, so these are smaller numbers. The times when you really do want to use a vertical or horizontal method over algebra tiles is when your coefficients get larger, because using algebra tiles for really large coefficients is a lot more effort and work. You can still do it, it's just more difficult. All right, so this is our first method. Again, we are looking with that website and using algebra tiles. So right now you guys are on a split screen in your Pear Deck, where you have the Mathagon polypad open, along with the Pear Deck slide that we're on. All right, and you know, this is one of those sites that you can bookmark. Haven't done it yet, but I'm going to do it right now so I don't forget. I'm going to copy this link address, and if I go to our week at a glance, this link right here for websites we use, this is going to be a website we use, so I'm going to add it to what we already have in here. It won't let me open it. I'm not, I have to open it all the way. Math gone. All right, so there's a link to get to it if you don't want to have it bookmarked or type it in or whatever. So anyhow, we're going to subtract with algebra tiles for this first problem. The key is the same with addition, okay? We're still representing constants. One is with these smaller squares. X, a single X is with the long rectangle here. And then the bigger square is for the x squareds and negative x squared. So to subtract polynomials, you need to remember that subtraction is equivalent to the addition of the opposite, such as 5 minus 6 can be rewritten as 5 plus negative 6. So polynomial subtraction is the same idea. To subtract polynomial b from polynomial a, we create a new polynomial, c, that consists of the opposite of each monomial in polynomial b. Then we can just add polynomial in a and c together. So when we subtract polynomials with algebra tiles, and basically all these methods, this is true for all the methods, is we're going to rewrite the second polynomial as the opposite of all those terms. Okay, when using tiles, we switch every tile in the polynomial being subtracted for its opposite. The tile is the same size, but the opposite sign. Once this is done, place the tiles representing the first polynomial in the new set of tiles next to each other and add like you have done previously, like we did last week. So the opposite of a polynomial is just the negative of it. When you add a polynomial to its opposite, you get 0. 0 pairs, remember that? So we're going to take this and use algebra tiles to represent it. We have 2x squared plus 4 minus 4x squared. And I did find out that I can put text on this tool. So if I click on the T, you can even draw. That's nice. Okay, so I'm going to use the text tool right now, though. But up here at the top, I'm going to type out 2x squared. I'm going to use the shift 6 to show that this is an exponent of 2 plus 4 we're subtracting this polynomial, 4x squared. So I can move this around, all right? So let's go ahead and do what it says here. We're going to rewrite the second polynomial as changing it to adding the opposite. The second polynomial is a monomial. It only has one term. So I only have to change the sign of one term. I didn't change anything on the first polynomial. 2x squared plus 4 is a binomial, has two terms, stays exactly the same. But I am going to change it to adding the opposite. So instead of minus, I'm going to have plus. And then instead of positive 4x squared, we're going to have negative 4x to the second power. Okay, so I changed it to adding the opposite. Now I can show this with algebra tiles. So 2x squared means I have 2x squareds plus 4. I have 4 of these orange colored ones. So this represents the first binomial of 2x squared plus 4. And now I'm adding to it the opposite of what I had before, because to do subtraction, we change it to an addition problem. So I want to represent negative 4x squared. So that means I have 1, 2, 3, 4 negative x squareds. Okay, so far I've just represented the two polynomials with algebra tiles. Okay, and so what I want to do now is I'm going to try to create some zero pairs to simplify this. This is addition. So this and this, give me a zero pair. This and this, give me a zero pair. And that's it. So my final answer here is just, I have 2 negative x squareds, and then I have 4 ones. So that's actually the answer to this problem. It's negative 2x squared plus 4. So after I've done all that work, the solution then is, and maybe I'll just put it up here. This equals negative 2x to the second power plus 4. Okay. So you can add text to these. You also have the drawing tool if you want to use that. All right. So I'm going to give you a minute to go ahead and try and play around with this a little bit, and then we're going to go on to the next method. You guys have any questions on using algebra tiles? Okay. Are you guys ready to move on to the next method? We're going to look at the same 3 methods that we had for addition, but now we're using subtraction. And really the only difference here is that we take this subtraction problem and we turn it into an addition problem, and then we do what we did last week. Okay? So anyhow, I'm going to go ahead and move you guys forward. Okay, so I'm not going to leave you on student pace yet. You will be on student pace at the end, but for right now, I'm going to make you go to the next slide with me, which is the second method, subtracting polynomials using a vertical format. So in order to do that, we need to rewrite the subtraction as addition of the opposite, just like we did in the last method. And so here's what we're starting with. We're starting with this binomial, 5x plus 2, and we're subtracting this polynomial or trinomial, negative 2x squared minus 3x plus 4. So the first step with subtraction is to rewrite the second one as addition of the opposite. So we change the subtraction to addition. And then we have to change the sign of everything inside. Okay, another way to think about this is it's like you're distributing negative 1 through. Okay, so that's one way to think about it. Think about distributing negative 1 through the polynomial. Okay, so when you are actually rewriting it, okay, you're actually like distributing negative 1. So negative 1 times negative 2x squared is positive 2x squared. Negative 3x times negative 1 is positive 3x. Positive 4 times negative 1 is negative 4. You can also just think of it as changing the sign on each term. So there's 2 ways you can think about it. Or think about changing the sign on each term. So let me change the size of that. All right. So that's just, you can add notes to your slides or add notes to your notes. But to help you figure out what you're doing, you could think about distributing negative 1 through the whole second polynomial, or you could think about just changing the sign on each term. All right. But this is what we get. And now we're going to go back to what we learned last week, and we're going to line up vertically terms that have the same variable part. All right. So I'm going to just kind of show you here. I have 5x, right? And that's just a single x. This is a single x too. I have a constant of 2, and then I have a constant of -4 here. So the green ones will get lined up, the blue ones will get lined up, but I also have this x squared term, 2x squared. So when I put 2x squared here, I need to put a 0 placeholder above it. So add a 0 placeholder term for any missing type of term, I guess you could say. Okay, so that's basically what we just did right here. We just added a 0 placeholder right above the 2x squared term because we didn't have one, right? So that's why there's a 0 there. But my 5x and my 3x are lined up. My +2 and my -4 are lined up. All right. You see here, we're using the vertical method. Write 0x squared as a placeholder. Okay. And then the last step is to just combine your like terms. So you're adding vertically, and it doesn't matter. You can go from left to right or from right to left, whatever you want to do. If you feel like it's more familiar going from left to right or right to left, whatever way you want to do it, it's the same answer. You're not carrying anything like you would with the vertical addition of like, 99 plus 87. You wouldn't be carrying anything. It doesn't work that way with polynomial addition. So right here, I'm going to put a little note that you can add each column either from right to left or left to right. It doesn't matter. All right, so if we start over here, 2 plus -4 is -2, 5x plus 3x is 8x, 0x squared plus 2x squared is 2x squared. And then, sometimes you have to simplify a little bit more, but this is eventually what you get to. So we're going to try another one of these, a little more interactive with you guys. Right now, I have 3 people that are writing on this slide so far. And so that number really needs to improve. So one of those is me. Where's the rest of you? Okay, you guys should be writing on here. We're going to do the second problem. Y squared plus y minus 1. That's our first polynomial. Our first trinomial has 3 terms. Trinomials have 3 terms. Minus our second polynomial, which is also a trinomial, -2y squared plus y plus 1. First thing here, it says rewrite subtraction as addition of the opposite. Okay, so that's where in the red text here, we're thinking about distributing -1 through the entire second polynomial, or we're thinking about just changing the sign of each term in the trinomial. So if it was -2y squared before, it's going to be +2y squared next. So I'm going to put a plus sign right here. +2y squared. We had +y here, so this changes to -y, minus y. And then we had a +1 here, so this changes to -1. All right, so you have to rewrite each term with the opposite sign, and you have to change it from subtraction to addition. Don't forget to do that as well. All right, and now we're going to line these up. Okay, our first term is a y squared term. Okay, and we have another y squared term right here. That's good. For the x terms, or the y term, sorry, single y term, we have a single y here and a single -y here. And for the constants, we have a -1 right here and a -1 right here. So we actually have no need to use any 0 placeholders because Everything has a like term to match up with. Okay, so I'm going to just type out first term here, or the first polynomial, excuse me, y squared plus y minus 1. And then beneath that, I'm going to put plus 2y squared minus y minus 1. Right? Then last thing here is to combine those like terms and simplify. Again, you can go from left to right or right to left, doesn't matter. You know, if you don't see a coefficient from the y squared, remember it is 1y squared. So 1y squared plus 2y squared is 3y squared. Y plus negative y, that's actually going to give me 0. Again, you can add in the coefficient that you don't see, which is positive 1 and negative 1. That still adds to 0. And then negative 1 plus negative 2 is negative 2. I simplify this just a little bit. I don't need to write that plus 0 there. So I have 3y squared minus 2. So that would be the final answer for that one. I have 7 of you writing on your slide, or 6. Okay. So like it's good if you add the same things that I'm typing. That's a good way to, you know, have these so that they'll help you later on. All right, but I do understand it is difficult to use Pear Deck with the Chromebook, especially if you don't have a mouse. We're just doing the best we can virtually, right? At the very least, you need to fill in the blanks. Plus, minus, minus. And then you need to write what I wrote here in black. You need to write those equations and adding them together. So we are on method 2. We got one more method to learn. Okay, so I'm going to leave this up here for a minute while you get caught up. We have 2 more slides to do. During your async time today, you're going to be doing an iTime, which I haven't assigned yet. I mean, there's no Pear Deck link yet. I'll give it to you once we're done with our lesson. I am recording this, so you know, if I do go too fast, you can always go back, rewatch the video. You know, if at the end you don't understand, go back and watch the video again from the beginning. Okay, maybe you're missing something that you just didn't hear. All right, so we're gonna move on to the last method. Again, at the end, I'll leave it in student pace and you could go back and fix anything that you missed. Last method here, method 3, subtracting polynomials using a horizontal format. All right, once the subtraction problem has been rewritten as a sum, the polynomials can be added using the horizontal method, just like we used last week for addition of polynomials. Recall that this method uses the associative, commutative, and distributive properties to group and combine like terms. So the reason why we're allowed to do this method is because of these properties here. So we're starting with this trinomial 2q squared minus q minus 8 minus this trinomial 2q squared plus q minus 4. Trinomial subtracting a trinomial. You need to rewrite it so that you're adding the opposite. Okay, the minus becomes a plus. Positive 2q squared becomes negative 2q squared. Positive q becomes negative q. Negative 4 becomes positive 4. And now what you can do is drop these parentheses, okay? And we're using associative and commutative properties to move stuff around so we have all the like terms together. Let me see, what colors did I use? I want to be a little consistent here. So pink, green, and blue. All right. So we have a 2q squared and a negative 2q squared. We have a minus q and a minus q. I'm just underlining them because they're like constants, negative 8 and positive 4. So that's why we're able to put negative 8 plus 4 together. Why we can put minus q together. And why we could put 2q squared minus 2q squared together. So we grouped all the like terms together. And now we just go through and simplify each grouping. This is the distributive property, essentially. What you're doing is factoring out. You're using the distributive property in reverse to pull out q squared from each term. So what you're left with is 2 minus 2, which is 0. 0 times q squared is nothing. So this term completely drops out. It's gone entirely. Negative q minus q. Negative q plus negative q. This is not nothing. This is actually negative 2q. Negative 8 plus 4. When you add opposite signed integers, you actually subtract to keep the sign of the bigger absolute value. So it's negative 4. And that's your final answer. So let's do that now with this second part. We have 2ab minus b plus a. 2b squared plus b plus a plus 4. So we have a trinomial and a polynomial with 4 terms. There might be a name for that. I don't know what it is. You don't need to know what it is. You just need to know up to 3 terms. 1 term is monomial, 2 term is binomial, 3 terms is trinomial. So looking for like terms, right? You can use some color to go through. Well, there's a b squared term. I don't have a b squared term over here. There's a b term by itself. I have one over here, a negative b by itself. We have a in these ones. So here's an a by itself. Here's an a by itself. A and b are different variables. So I don't like if they're the same variable. So not only do they have to be the same variable, they have to have the same power. And we have a constant. We have plus 4 on this side, no constants over here. I do have this extra term, 2ab, okay, that I don't have on this side. So this is by itself, a different color for it altogether. So there's lots of different types of terms. We have 1, 2, 3, 4, 5 different types of groupings when we group together here. Before we do that, though, we want to rewrite subtraction as the addition of the opposites. So coming through with text, this is going to become negative 2 b to the second power minus b minus a minus 4. We took each term and changed its sign. And now we're going to group our terms together. These all stayed the same, but you know, these have changed signs now. So I'm going to write out here. Let's go with the highest powered term first, which is negative 2b. You guys should be following along on yours. Negative 2b to the second power plus 2ab plus We'll put these in parentheses, negative b minus b. Right? And plus a minus a, and plus negative 4. All right, so I could put the parentheses here too. And it makes you see how there is exactly 5 groups, because there are 5 different types of terms amongst the 2 polynomials. We had 5 types of terms. Oops. All right, and now we're going to simplify it. So, you know, if it's a term by itself, you can't do anything. You just rewrite it. So these first 2 terms are by themselves, so we're just going to rewrite them. Negative 2b to the 2nd power plus 2ab. Next set parentheses, negative b minus b. That is not 0. Okay, they're not opposites. They both have a coefficient of negative 1. Even though you don't see it, we add it in, right? There's 1 there. So negative 1b plus negative 1b is negative 2b. A minus a. Well, these are opposites. Again, you don't see the coefficient, but there's really a positive 1 there. And there's really a negative 1 here. So whenever you add opposites, they get canceled out. This is actually just 0. It goes away entirely. And then our last term here, all by itself, nothing else was a constant. So we just add it to our final polynomial of either plus negative 4, or you can even write minus 4. That would also work. Okay, so I'm going to leave this here for another minute, and then we're going to move on to our last slide. Yeah, I think when you're trying to do exponents in Pear Deck, probably the easiest way to get that done is to use Shift 6, and that would give you that little like pointing up arrow symbol, which means you have an exponent. That's pretty standard. I am going to put you on student pace. All right. And the last problem, you can get started on this. So I'm going to leave this up here for another minute. Okay, because I know some of you are still copying it. You can always go back to the video if you're not fast enough. But if you are done copying, move forward to the last slide, slide 7. It says subtract the polynomials using any of the 3 methods you prefer. And so it's a story problem. The number of gallons of water in a leaking pool is determined by the rate that the water is filling, 8g squared plus 3g minus 4, and the rate that the water leaks from the pool, 9g squared minus 2g minus 5, where g represents the number of gallons entering or leaving the pool per minute. Write an expression for the net change in gallons per minute of the water in the pool. Find the change in the amount when the rate g is 5 gallons per minute. So not only are we going to find the difference of those 2 polynomials, we're also going to figure out the amount when g equals 5. All right, so let's go ahead. We'll go to the next slide. And I'm going to turn off student pace just to get you guys to go to the slide I need you to be on right now. Well, let's first write an expression for what it is we're going to be subtracting, all right? And, you can underline your two expressions. So this is one we need here, 8g squared plus 3g minus 4. The other one we need is 9g squared minus 2g minus 5. So first we're going to subtract those guys. 8g squared plus 3g minus 4 minus, in parentheses, 9g squared minus 2g minus 5. All right. I am going to use the link to get to Mathagon. I'm just going to put it over here. Oops. All right. I like using Mathagon, and these numbers are not so big that you can't use it. I do want to show you how to use that because some of us are visual learners and it helps. But one thing I'm going to do here is the same steps we've been doing. Every time we do a subtraction problem, the first step is always the same no matter what method you're using. And that's to change it to adding the opposite. So my subtraction turns into addition. And then I rewrite each term as its opposite. So instead of positive 9g squared, I now have negative 9g squared. Instead of negative 2g, I now have positive 2g. Instead of negative or minus 5, I have plus. Okay. And since I have that, and I could come over here and represent that, okay, 8g squared means I have 8 of these. If I put one up, I can go to this copy button and click it. They are just more of the same. There's 4, 5, 6, 7, 8. I have 3 g's. And remember, guys, if you have a different variable here than you have here, it's okay because you're just using this as a visual tool. Minus 4. I have 4 of those. Okay, so that's my first polynomial. Here is 8g squared because there are 8 blue x squareds. This is 3g because there's 3 of the variable x, which is g. And minus 4 is 4 pink negative ones. And now I'm going to add negative 9g squared. So that's negative 9 of these. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And 2g. And 5. Oops, that guy shouldn't be there. Okay, 5 of these. Right, so visually, if you're using Mathagon, the polypad, this is what you have. And the method now, using this one, is to create zero pairs. So here's a zero pair. Here's a zero pair. When you have a zero pair, it just gets taken out of the entire situation. And they changed colors. They changed to gray. They're meant to do that so that it's like they don't count. They're just canceling each other out. So look at that. After all those big blue and pink squares, we have one x squared left. With the x's, or my g's, nothing cancels. So we have all of them left. With these, there's a zero pair, zero pair, zero pair, and a zero pair, so I'm left with just one. So here's one way to do it. You can use Mathagon polypad to get negative x to the second power. Not x, my bad. So that's easy to do, right? Switch your variable because you're looking at x, but it's actually g. So we have 1 negative g squared plus 1, 2, 3, 4, 5 x's is the same as 5 g's. 5g. And the constant plus 1. All right. Okay. This can also be done with the vertical or horizontal method. They would all give you the same exact answer. This is the end of this lesson. I am